Black holes are among the most mysterious and fascinating objects in the universe. They seem to defy our understanding of how the cosmos works. But where do they come from, and what happens if you get too close to one? Stars are gigantic balls of gas made mostly of hydrogen that form when immense clouds of gas and dust collapse under their own gravity. At their cores, the pressure and temperature become so intense that the hydrogen atoms are crushed together to form helium. This process, called nuclear fission, releases an enormous amount of energy. This energy pushes outward as radiation, balancing the inward pull of gravity. It's this balance between the energy trying to blow the star apart and gravity trying to crush it that keeps the star stable. But what happens when that balance is broken? That's where the story of black holes begins. A star stays stable as long as fusion happens in its course. For very massive stars, the heat and pressures are so intense that they can fuse heavier elements. But when they start making iron, the process stops producing energy, unlike the earlier stages of fusion. Iron piles up in the star's core until it can't hold the balance between gravity and radiation. The core collapses and the star implodes in an instant, with parts rushing inward at a quarter of the speed of light. This violent event, a supernova, creates all the heavy elements in the universe. After the explosion, the core becomes either a neutron star, or if the star is massive enough, a black hole. A black hole's surface, called the event horizon, marks the point of no return. Nothing can escape from it, not even light. This means nothing can escape, so we see a black sphere that reflects no light. But what is inside the hole? It's called the singularity, a point where all the mass is squeezed into an incredibly tiny space. We're not sure what it really is, but it might be infinitely dense or something entirely unknown. We don't fully understand singularities, yet it's like a divide by zero error. Also, black holes don't suck things in like vacuums. If the sun were replaced by a black hole of the same mass, Earth's orbit wouldn't change, but we would freeze without sunlight. If you fell into a black hole, time would slow down for you as you approach the event horizon, at least from an outside perspective. From the outside, you would seem frozen in time, turning red before fading away. But from your view, the universe would speed up, almost like watching the future unfold. What happened next is unclear, but one possibility is a quick and sudden death. A black hole bends space so much that once you cross the event horizon, there's only one direction to go deeper inside. It's like being in a narrow alley that closes behind you with each step. The intense gravity is so strong that even tiny distances, like a few centimeters, create massive differences in force, stretching your body with incredible power. As you fall in, gravity stretches your body until your cells are torn apart, leaving you as a thin stream of plasma. Another possibility is hitting a firewall near the event horizon, which would destroy you instantly. How quickly this happens depends on the black hole's size, but neither outcome is pleasant. A small black hole would kill you before you even reach its event horizon, but a supermassive black hole might let you survive as you fall inside. The farther you are from the singularity, the longer you will live. Black holes come in different sizes, from stellar black holes a few times the mass of the Sun to supermassive ones with much larger diameters. Supermassive black holes sit at the center of galaxies and have been growing for billions of years. The largest known is S50014+81, with mass 40 billion times that of our Sun. Its diameter is 236.7 billion kilometers, 47 times the distance from the Sun to Pluto. Despite their power, black holes will eventually disappear through Hawking radiation. Empty space isn't truly empty, it's full of virtual particles that briefly appear and destroy each other. Near a black hole's edge, one particle can fall in while the other escapes, becoming real and slowly draining the black hole's energy. As the black hole loses energy, it shrinks and radiates more heat. At asteroid size, it radiates at room temperature. When it is as small as a mountain, it shines as hot as sun. In its final moment, it releases the energy of billions of nuclear bombs in a massive explosion. The evaporation of a black hole is extremely slow. The largest one could take a gaggle years to disappear, a time so long that the universe will already be uninhabitable, with no one around to see. But this isn't the end of the story. There is much more to learn about black holes in future videos.